Hi everybody, very welcome to Mentor and yet another video podcast. As always, I hope you're doing absolutely fantastic. So, did you know that when you're flying most commercial aircraft, you're actually breathing air that's coming directly from the jet engine? Today we're going to be talking about the air conditioning system and the bleed air system on the 737, so stay tuned.
Wind 310 16, everyone right, set on right. Third line, 31 right. Delta 26.
This video is brought to you together with Audible. Now, if you're like me, you love kind of sitting back, relaxing, listening to a great audiobook or maybe a comedy show or a news show, well, in that case, I highly recommend you to check out Audible. So if you use the link here below, which is audible.com/mentorpilot, or if you're in the United States and you text the code mentorpilot to 500 well, then you'll get 30 days of free trial with Audible. You'll get 1 free audiobook and 2 Audible originals. So check it out. So if we start off with where bleed air comes from and why we have it in the first place. And the fact is that an aircraft, especially as old as the 737 is, needs bleed air for a number of different reasons. So we're using bleed air to start up the engines. We're using it to anti-ice and de-ice the front of the engine cowling, as in when the air comes into the engine, and also the leading edges of the wings. It is used to pressurize the water tanks so that you get water when you open up the taps in the toilets, and also crucially, it's what regulates the temperature and makes it possible to breathe inside of the aircraft when you're flying. The bleed air can come from basically 3 different sources. So either it can come from an external air source. This is something we would use if the auxiliary power unit, which is the second bleed air source, is not working. And an external air source, I have used it actually this week. The APU wasn't working, and you'll see it as a huge kind of compressor wagon that makes a lot of noise and stands next to the aircraft, and it uploads air in order for us just to start our engines, so we get to our third bleed air source, which are the engines of the aircraft. So when we are flying along, we use the compressor stages of the jet engine to provide the pressurization and the air that we're breathing inside of the aircraft. We use air from the 5th and the 9th stage of the compressor. And the way that the jet engine works prior to the burn chamber is that it will take in air from behind the fan in through several compressor stages that will compress the air in, and then add fuel to that compressed air and burn it in the burn chamber. Okay, and we take a little bit of that compressed air in order to feed these systems that I just told you about. This also means that we're actually taking away a little bit of the power of the engine by doing so. We're sacrificing a little bit of the fuel efficiency from the engine in order to get bleed air for all of these systems. And this is why, if you look at more modern aircraft like the Boeing 787 Dreamliner, for example, they have stopped doing that. They're using electrically driven compressors instead, and that is to get the absolute best fuel economy out of the engines. But in the 60s kind of technology, or 90s engine technology like we're using on the 737-800, we were still using bleed air from the engine. So primarily the bleed air comes from the 5th compressor stage, but we can also, in case we have very low power setting on the engine, bleed a bit of air from the 9th stage as well, and that's the kind of supplementary bleed air source. We have 2 different systems, as always. You know that by now. There's always a backup system in case one would not work, the other one can take up the load. And the way this works is that the bleed air is taken out of the engine. It's then being rerouted through several kind of pressure switches and temperature switches that can stop it in case it feels an overpressure and over temperature condition. It's then being routed out to the anti-icing system if it's needed, and then it's being brought into what we call the air conditioning packs. The packs are basically what's controlling the pressurization and the temperature that you're feeling inside of the aircraft. And the way that this works is that this bleed air, when it's coming into the pack, it is very, very hot. You know that if you know your physics, that if you compress air, it becomes very hot, and it's way too hot to be fed into the passenger compartment. So it comes in and it goes through a heat exchanger. Now, if you've seen a 737 when you've been boarding it, you can see that just in front and below where the wings intersect with the body, there are openings. These are ram air openings. So it, like the word would suggest, it takes the air that's ramming into the opening, it brings that through, and it uses it to cool down the bleed air. So the bleed air goes through a heat exchanger that uses the ram air to cool it down. It then moves into a refrigeration unit that refrigerates it. It's called an air cycle machine. And then it goes to a water separator, right, that separates and takes away the moisture out of the air. That's why, by the way, you always feel so dry when you've been flying, especially long haul, because the air is really dry. Then, as it's gone through this process, it's now very cold. And depending on what temperature we want, we can then add a little bit of bleed air that has been kind of rerouted past this refrigeration system and added hot air towards the last stage to set the temperature. So this looks exactly the same on the left side and the right side. So the left pack uses the bleed air from the engine number 1, the one on the left side, and the right pack uses it from the right engine. And these systems then come together in what's called the mix manifold. Now, there is what we call an isolation valve, so it is possible to completely separate the systems from each other. If you have a bleed air leak or, for example, an engine failure or an engine fire on one side, you can separate the systems to make sure that none of that bad air is rerouted into the cabin. But the left pack is the pack that on the 737 supplies the air to the flight deck. So from the left pack, some of the air goes into the flight deck, and since that's only a tiny little bit, the rest of the air goes into the mix manifold. It's been mixed up with the air from the right pack, and then it is being fed into the cabin. The cabin is divided into two different zones, the forward and the aft zone, and we have temperature controllers inside of the cockpit where we can set it. It's a very rudimentary system. Picture like a Volkswagen Beetle from the 60s or 70s. It is that system, right? We don't set a digital temperature. We actually have a little knob that goes to either hotter or colder. You don't get me there. It's probably one of the worst systems on the 737. But anyway, this is also why, which I mentioned in a previous podcast, if we would have a bird strike, for example, we can actually figure out which engine has been hit by the bird depending on where the smell comes from. Because if a bird has gone into the core of the engine on the left-hand side, well then the smell of burnt bird will go through the bleed air system and it will end up in the cockpit first. But if the smell comes out, if the cabin crew starts telling us that it smelled like burnt bird in the back, well then we know that it's the right side, because then the bleed air has been coming from that side. So you can actually make that distinction, and it's very, very clear when it happens. Anyway, the air that comes from the mix manifold is now being pushed up and into the cabin. If you have had the bad luck of buying a window seat and you end up on the 737 without a window at your window seat, that's because you're sitting where the air is coming up and going up into the rises that's above in the roof of the cabin. There's also rises on the side of the cabin, and all of that makes a nice mixture of air inside of the cabin. When the cabin air has been used, so when you guys have been breathing it for a while, it's being sucked out from the bottom of the cabin and is being routed around the forward cargo bay, and it's used there to heat up the forward cargo bay. And then it is either being exhausted, going out to the overboard exhaust valve, which is there and is used during very low differential pressures, but I'll get to that in a second, or it is being exhausted by the big hole in the back, which is the outflow valve, which is the main kind of regulator we have for regulating the pressure in the cabin. Or a quite big bit of it is being used and being filtered first and then recirculated into the mixed manifold. And we reuse the air in order to take a little bit of strain off the packs, because the less the packs have to work, the less bleed air we have to take from the engines, the less fuel we're using. So you are actually breathing a little bit of reused air inside of the cabin, but it has been properly filtrated before that happens. Okay? Right, so that's how we manage the temperature. But what about the pressurization? Why do we need to pressurize the cabin in the first place? Well, the fact is that us humans, we were not built to be, hanging around at 40,000 feet. We were built to be walking around on the surface of the Earth. So our lungs are built to take up oxygen, the amount of oxygen we need at the pressure that is on the surface. If we start climbing, the pressure will gradually decrease as we get higher. And at some point, around 25,000 feet and above, we cannot take up enough oxygen to live anymore. This is called the death zone. This is what you probably heard about when climbers reach this zone when they're climbing Mount Everest. This is where they need to start using oxygen or be very, very well prepared. Otherwise, they will not be able to do it. We climb well above that. So our cruising altitude can be anything from 35 to 41,000 feet. And up there, in order for you to be able to breathe, the cabin needs to be pressurized, or you need to breathe pure oxygen. But you don't really want to sit with an oxygen mask on. You wouldn't want to be able to eat your snacks and have your drinks and talk to the people that you're traveling with. So we pressurize the cabin. We're doing so by feeding from the air conditioning packs in enough air to keep the pressure similar to what's on the surface, but it's not going to be exactly like it is on the surface, and I'll get to that soon. So the outflow valve in the back is being controlled by 2 automatic pressurization controllers that make sure that the pressurization is kept within limits, and it drives from open to decrease the pressure, to close to increase the pressure on board. And the way that we pressurize it, and this is fascinating, is that we will set takeoff thrust. And when we set takeoff thrust, the outflow valve will drive to close. And when it comes to close, we will start to pressurize the cabin. So this means that the cabin altitude, as in the altitude that is in the cabin, will actually decrease a little bit initially. And this is to make the transition from unpressurized to pressurized flight feel less for you. You will feel it less by doing it this way. So you start slightly pressurized, we take off, and as we start climbing, the cabin altitude will be climbing as well at a rate that is proportional to the rate that we're climbing with the aircraft. So if we're climbing with 3,000 feet per minute, the cabin will be climbing at about 500 feet per minute or so. When we're leveling off, the cabin levels off as well. And when we reach our cruising altitude of about, say, 41,000 feet, the cabin will level off at a maximum altitude of 8,000 feet. So you're actually sitting at about 8,000 feet altitude when you're up at the cruising level. And this is why you feel sometimes that you might have problems with your ears, problems with your sinuses, and if you have like a bag of chips or something with you, you'll see that it's about to pop when you're at the cruising level. And that is because you are actually at a fairly high level. We will maintain that. Right? If we do a slight climb, the cabin will climb as well, but not above approximately 8,000 feet. And then as we start descending, when we descend more than about 0.25 psi of pressure, then the automatic controller will feel that we're in a descend mode, and it will start to gradually descend the cabin as well. So it will follow, once again, a proportional rate of descent down to when we get onto approach. It will then continue to pressurize the aircraft so that we land once again with the aircraft slightly pressurized. And that is to make sure that we don't get that kind of sudden poke, sudden like click in your ears as we touch down. So once again, you're going to be landing slightly lower, at a slightly lower cabin altitude than what the aircraft actually is at. And as we taxi in, the automatic controllers will gradually open the outflow valve to make sure that the aircraft is completely depressurized during the taxi-in phase so that we are able to open the doors. If that didn't happen and the aircraft wasn't depressurized, we wouldn't be able to open the doors, and that would be a problem. So the pressurization system, like I said, has 2 different automatic controllers. They alternate between each flight. So one on one flight, second one then on the next flight, and if one fails, the other one automatically takes over. If both of them fails, well, then we have a manual mode as well, so we, the pilots, can manually manage the pressurization of the aircraft. But a problem that we have with this system is that if something happens, for example to the outflow valve, well, then the aircraft might suddenly and abruptly depressurize itself. And you've probably seen that in newspaper articles where it says that the aircraft suddenly fell from 30,000 feet and the masks dropped and it was chaos in the cabin. Now, the reason for that is what I just told you. We need to have a certain pressure for us to be able to breathe. And if the pressurization suddenly drops, be it by a problem with the outflow valve or a structural problem with the aircraft, well, in that case, we need to quickly get down to an altitude where you guys can breathe. Now, the oxygen mask that drops down, they will give you enough oxygen to survive during the emergency descent. There's about 13 minutes of oxygen that can be produced by the oxygen generators that are, providing the oxygen. They're not actually oxygen bottles, they are chemical reactions that gives you the oxygen. This is also why you might smell a faint burning smell if this happens, because the oxygen generators actually get quite hot when they're generating the oxygen. But if you're interested in knowing what we do, when the passengers are feeling that falling feeling and that chaotic feeling, if you want to see what that actually looks like from the cockpit, then I've done a video about a rapid depressurization and emergency descent, how that looks in the cockpit. So you can click the link here or check out the link in the description of the video. Now, what I would suggest if you are looking at that video is to put the subtitles on, because it can be a little bit hard to hear what we're saying through the oxygen mask. But it's fascinating and I highly recommend it. But in essence, guys, this is why we have a bleed air system on the 737. We need it in order for you guys to have a nice and survivable ride. We need it in order to start the engines in the first place. We needed to de-ice the wings and the engines. And the system is actually very, very good and very reliable. Guys, if you have more questions about the pressurization system, maybe you want something further clarified, well then put your comments in here, or even more effective, get the free Mentor Aviation app. I will be in there, just tag @mentor and I'll be answering your questions, or there will be other professional pilots or pilot students or aviation enthusiasts and even people who are nervous flyers in the forums. There are no stupid questions, everyone are welcome. It's a fully safe, positive and constructive environment. So go down, there are links to download it both for iOS and Android down here, and join the community. I also want to send a huge thank you to the sponsor of this episode, which is Audible. Now, I spend a lot of time transitioning in between bases or flying as passive crew up to my training assignments in Stansted or in Bergamo or whatever it might be. And I love hanging out listening to a great audiobook. Now, Audible has an unmatched library of audiobooks, and if you use this